Okay, today we're going to define the derivative of functions using basic differentiation rules. Alright, but up to this point, how do we know how to find the derivative? What do we use?
The limit of the difference quotient.
Limit of the difference quotient. Okay. Now, we also talked about using the alternative form, but I can only use the alternative form when I'm finding slope. Okay. If I want the derivative, I have to use the limit of the difference quotient. If I'm finding the slope, then I can use the alternative form. But today, we're going to use basic differentiation rules instead of the limit process. And there are 4 different types of rules. The first one is the constant rule. The constant rule, if I want to take the derivative of a constant, what do you think the derivative of a constant is? No. The derivative of a constant is
The constant.
0. Okay, and if you'll notice, the way I have written the y, that is how we denote that we're talking about a derivative. That is pronounced y prime. You will also see it as dy dx. You can also see it as f prime of x. Those all stand for the derivative. So y prime, dy dx, f prime of x, those all stand for the derivative. Alright, so that's the constant rule. The derivative of a constant is 0. Next we have the power rule. So let's say I have y equals x cubed and I want to find the derivative. Ryan, what's the power rule? Do you remember? Zach?
Is that where you take the power or multiply the variable by the power and take 1 out of it?
Alright, so I bring the exponent down, which is 3, and I subtract 1 from the exponent, which is a square. So bring the exponent down and subtract 1 from the exponent. That is the power rule. Bring the exponent down, subtract 1. That gives you the power rule. Next is the constant multiple rule. So let's say I have y equals 2 times x to the 5th.
What rule is this?
This is the constant multiple rule, and it's really pretty basic. What it's saying is, if I have a constant coefficient, such as this 2, what's going to happen as I take the derivative to 2?
It's going to be multiplied by
You just multiply by the power.
Right, technically it stays there. So technically, here's what the constant multiple rule tells me, is that the 2 stays there, and then I just perform the power rule on x to the 5th. So that would bring down the 5, make it x to the 4th. So I end up with 10x to the 4th. Obviously, we can go from here to there. But the constant multiple rule is that if I have a constant coefficient, the constant coefficient stays there. And then it's just multiplied in once I find the derivative. All right. Then my last one is the sum or difference rule. So the sum or difference rule is if I have some monomials that are added or subtracted. Okay. So far today we've only dealt with taking the derivative of a monomial. Now I'm taking the derivative of a polynomial. And what do I do to take the derivative of a polynomial?
You do 1.
Right, I just take the derivative of each of them and then subtract them together. So the derivative of x cubed would be
3x squared.
3x squared. The derivative of negative 2x, just negative 2. What technically happens to the x? It has an exponent of 0, and anything to the 0 power is 1. So my derivative ends up being 3x squared minus 2. So those are your 4 basic power rules. Derivative of a constant is
0.
0. The power rule, bring the power down, subtract 1 from the power. Constant multiple rule, if it's a constant coefficient, it stays there. And then the last one is if I'm adding or subtracting monomials, I just take the derivative of each one of them separately. Any questions on those basic rules? What's the difference between a constant and a constant coefficient? We need to make sure we know the difference between those two. A constant coefficient is always attached to what? A variable. A constant coefficient is attached to a variable. A constant is not attached to anything. So a constant is going to be by itself. So anytime I've got a constant that's by itself, the derivative of it is 0. But if it's a constant coefficient, what happens to the constant coefficient? It stays. That's the main difference. Alright, let's run through some examples then. Alright, I have f of x equals 3x to the 7th. Melody, what's my derivative?
21x to the 6th.
21x to the 6th. Any questions on that one?
When you do this, what rule are you doing?
Okay, what rule did I use on this one?
Does it matter
I
what
used the power rule and I used the constant multiple rule. Yeah, but I really don't have, you don't have to tell me what rule. I'm going to go through and ask you what rules I used today, but after today I'm not going to ask you what rule did you use. Okay?
like on our homework, he's gonna tell us what rule we're gonna use?
No, it's just going to say find the derivative. So you got to know what to do. But yes, on this one we use the constant multiple rule and we use the power rule. My next one I have g of x equals 2 over x to the 5th.
Would it be 2 over 5x to the 4th?
No.
Negative 2 over 5x to the 1.
Negative 10 over x to the 6th.
Negative 10 over x to the 6th. Now let's talk about how I want you to do it. The first thing I want you to do is move that variable from the bottom to the top. And how do we move a variable from the bottom to the top?
Make it negative.
Make it a negative exponent. So move it up first, then take the derivative. So now I take the derivative, that's going to give me negative 10 x to the negative 6. You got to be careful with negative exponents because you'll want to give me, as most of you said, you gave me 4. But it is 6 because it's negative 5 minus 1, which gives me the negative 6. And then we want to move that exponent back down, which gives me negative 10 over x to the 6th. And when you move it back down, you got to be careful because sometimes some of you will want to do what when you move that?
Negative.
Move that when you move that x to the 6 down.
We'll move the 10.
You'll move the 10 with it. Don't move the 10 with it. You only move what has a negative exponent. The only thing with a negative exponent is the x. So that's the only thing that moves. We're going to have y equals 7 times the 4th root of x cubed.
You have 21 over 4 times
So what should I do first to this one?
Move that to a
make x equal
Put it in exponential form, which makes it 7x to the 3/4. Now I can take the derivative. So that's going to be 21 over 4 x to the what? Negative 1/4. So what my final answer look like?
Do you want to put
1 over 4
fourth.
over.
21 over 4 x to the 1/4 is fine. If you want to put it back in a radical form, you can. Make it 21 over 4 times the 4th root of x. I'm happy with either one of those. I have h of x equals x cubed plus 5x squared minus 3x plus 8.
3x squared plus 10x minus 3
So 3x squared plus 10x minus 3. Now in this problem we actually use all four rules we talked about today. I've got the constant over here, which is 8, and the derivative of a constant is 0. I've got the power rule right here of x cubed. And then I've got constant multiple here, and then all of it together is the sum or difference. So I actually used all 4 of my basic rules on that one.
So that's your answer.
That's my answer right here. Now, don't just give me this part. Okay, make sure you give me that over there as well. Make sure you tell me you're talking about the derivative. So h prime of x. Make sure you have h prime of x equals that.
On the test, we're going to use the limit process, right? Can we use this to check our answer before?
But yes, if I ask you to use the limit process, you have to show the work for the limit process. But yes, you can check your answer. Now g of t equals t squared minus 4 over t cubed. What do I want to do first to it?
Move your exponents to the numerator.
So g of t equals t squared minus 4t to the negative 3.
2t plus.
So my derivative is going to be 2t plus
12 over
12. Yeah, don't get ahead of me. It's initially going to be t to the what? Negative 4. So 2t plus, what does that end up being? 12 over t to the 4th. Don't get sucked into moving that 12 down. Only the variable goes.
Would you take the negative 4 or would you want to smooth it down?
Some kids I had last year, I like moving. I don't like answers with negative exponents in it. But some kids I had last year that have calculus this year said that their professors allow them to leave negative exponents in their answer. If you're doing a free response question, you can leave the negative exponent in there. They'll take it. I personally like you to get rid of the negative exponent. All right, 2 more examples. All right, I have f of x equals x cubed minus 3x squared plus 4 divided by x squared.
I'd
Move that to the numerator.
So you're saying that,
I think, yeah.
and then what?
Because then you have to, you can either work the inside or work the outside.
Nope, can't do that.
Oh, you have to work the outside first.
You have to distribute.
Can you just do the
Here's what I would rather you do.
Oh,
I would rather you take each part divided by x squared. So x cubed divided by x squared,
X?
x. Negative 3x squared divided by x squared. And then this is 4 divided by x squared, but I can write that as 4x to the negative 2. That's what I would rather you do. Now I can take the derivative. So the derivative of x is
negative
1. Derivative of negative 3, 0. Derivative of that,
negative
x to the negative 3. So I would like 1 minus 8 over x cubed. That's what I would like. And y equals the square root of x minus 6 times the cube root of x.
Change them into exponents.
Put them in exponent form. So x to the 1/2 minus 6x to the 1/3.
you have 1 over 2.
Alright, quit doing 2 steps at once for me. So that would be 1/2 x to the negative 1/2. This would be minus 2x to the negative 2/3. So that means y prime would be 1 over 2x to the 1/2 minus 2 over x to the 2/3. And if you want to make that 1 over 2 times the square root of x minus 2 over the cube root of x squared, you can do that as well. But you don't have to. I'm happy with that answer right now.